Listen to a canal, and you hear the friction between heavy timber and rushing water. It is a slow, deeply tactile environment. Long before we paved highways or laid steel tracks, we carved these artificial rivers directly into the earth. They were the primary arteries of global commerce, moving thousands of tons of cargo across dry land. The practice began around 4000 BC in Mesopotamia. Archaeologists mapping the region have found over 200 primary canals, originally dug as gravity-fed irrigation networks to redirect river water into surrounding farm fields. As empires expanded, the purpose of these trenches shifted from agriculture to logistics. By 214 BC, the Qin Empire in China was engineering massive waterways, like the Linghu Canal, specifically to transport military grain and secure its southern borders. But physics imposes a strict speed limit on this kind of transit.
As a narrowboat moves faster than a walking pace, the force of the wake physically undercuts the canal's edges, eroding the earthen banks and destroying the structural integrity of the channel. The engineers of the Industrial Revolution were frantic to move massive amounts of coal and steel as quickly as possible. Yet, to protect their own infrastructure, they were forced to build a transit network permanently bound to the speed of a walking horse. Constructing the main channel, known as the prism, required making porous earth completely watertight. Workers achieved this by lining the trenches with puddle clay, a thick paste of clay and water manually kneaded together to form an impenetrable barrier. The men who dug these thousands of miles of channels were called navvies, short for navigators. They were a nomadic labor force known for extreme physical stamina, often excavating up to 20 tons of earth in a single day using nothing but picks and shovels. Carving a flat trench is one thing, but crossing hilly terrain requires boats to climb. To solve this, engineers relied on the pound lock, a watertight chamber acting as a hydraulic elevator to lift or lower vessels between different elevations. The mechanics of the modern lock rely on the miter gate, a design popularized by Leonardo da Vinci in the 15th century. The system uses two heavy wooden doors that meet at a precise 18-degree angle pointing upstream. The genius of the 18-degree angle is that it weaponizes the water against itself. The immense directional pressure of the upstream current forces the angled leaves tightly together, creating a perfect watertight seal. Early canal engineering succeeded by negotiating with nature. Instead of deploying mechanical power to force heavy boats up a hill, builders harnessed gravity and ambient water pressure to do the heavy lifting for them. By the mid-19th century, railways began siphoning off lucrative freight contracts. To survive the severe cuts to their hauling rates, boatmen abandoned their houses on land and moved their entire families onto the vessels to eliminate rent. This birthed a distinct nomadic culture, defined by extreme physical constraints. Families of 6 or 7 people lived, cooked, and slept entirely within boat cabins measuring just 7 feet long. Surrounded by soot, coal dust, and the bleak landscapes of the industrial Midlands, these marginalized boating families developed a highly distinct folk art style known as roses and castles. The style relied on vibrant primary colors, featuring stylized floral garlands and romanticized mountain landscapes. Painters applied these bright motifs to every available surface, from the heavy cabin doors to buckbeak cans, which were the metal water containers kept on the roof of the boat. This high-gloss aesthetic served a specific social purpose. For a community that was highly isolated and often looked down upon by people on land, painting a pristine, romantic landscape on a coal barge was an act of psychological resilience and deep professional pride. As the 20th century progressed, the rise of the internal combustion engine and high-speed motorways finally outpaced the walking speed of the horse-drawn narrowboat, rendering the commercial canal networks obsolete. Today, however, these waterways serve a new function within modern urban planning as blue-green infrastructure.
Blue-green infrastructure refers to networks of natural water bodies and plant life designed to solve environmental challenges in dense cities. Preserved canal rings now provide vital ecological services to the concrete environments built up around them. They function as urban cooling corridors through water evaporation, while their unpaved banks create essential habitats for local biodiversity. They also represent massive economic assets. Historic networks, like the Grochtengordel in Ersenam, generate over €2 billion annually by supporting tourism, heritage preservation, and greatly improving the daily livability of the city. The canal survives as a liminal space, a transitional environment where rigid industrial engineering and natural ecosystems seamlessly overlap. It stands as an enduring monument to the simple, necessary act of moving slowly.